Calculus! This is lesson 4-7, circular related rates. This is definitely applied math because you can apply this to almost anything that is making a circle bigger or smaller. So maybe you have an oil spill. Maybe you have, because oil, again, like sits on the top of an ocean and usually gets bigger, just kind of like what would be another example? You might have an earthquake with shocks coming out in a circle. Not necessarily a circle because it goes faster.
A nuclear blast would be probably a circle.
Oh, we should do a nuclear blast problem. Yeah, maybe for next year. Oh, actually, we have a spherical related rate problem that we could do a nuclear blast also.
But spheres are harder than circles.
They are, but we do have to do spheres because 4-8 is going to be spheres, 4-9 is triangles.
Oh.
And by the way, there's our unit guide. That's our last 3 lessons. Circular, spherical, and triangular related rates. Then 4 self-checks, pretest, fix-up, and test. So we're getting really close to the end. So we just have a bunch of standard K, bunch of related rates.
Wait, so the self-checkups are basically 4.1 to 4.4, right?
Yes.
So the test is going to be between all those 4 lessons?
Well,
Or is it going to be the whole thing?
I mean, the self-checks apply to all 9 lessons.
Oh, okay.
Yeah.
So it's not correlated.
Yeah, there isn't any cross, like 4-1 doesn't just go on to self-check 4-1.
So maybe instead of self-check 4-1, it should be self-check 4.1.
Ah.
That might make more sense.
I think that actually gets changed in the future on other unit guides. At least it was last year. I need to probably update
Or
these.
you could do it based on the percentage of the total that each self-check is. If there's 4 self-checks, you start with 4.25, 4.5.
The average of them all or something. Yeah. That would be interesting. Food for that. All right, so let's go ahead and talk about geometry. Do you remember geometry? Our old friend area of a circle. What was our old friend area of a circle? That's definitely needed on the SAT, although they do give it to you, but you should definitely remember it because it is very fast to just know. That's for rectangle.
Pi r squared.
Pi r squared. There it is. Pi r squared. My pen width is a little bit off. I want it 1.5. Thank you. 1.6 is good. Let's see what it looks like now. Pi r squared. I like that. All right. Circumference. What is that? There's 2 formulas that you can use, but we're probably going to be using the same one over and over, using radius, not diameter. What is circumference? Uh-oh.
Pi d.
Pi d, yep. And then
Pi r.
there it is. Yeah, 2 pi r. Yeah, so if I was an ant walking around the circle, I'm walking a distance of the perimeter, 2 pi r. And then, oops, radius, that is, I guess I should have been labeling these. A is our area. C is our circumference. And R is our radius. Which is, I guess, D divided by 2 if you want a formula there. I guess just make it up on the fly.
Symmetrical. You have to make it match with all the other ones.
Yeah. I should have just been writing what those things stood for. Maybe I should have done a colon there. Teacher note, green, teacher note, do colons next time so I don't make that mistake again. Equal sign, usually think of formulas. All right, so what is a formula for area of a circle, Rochelle?
Pi r2.
Pi r
To the second power.
to the second power. Nice. All right, so we're going to take the derivative with respect to time. Not with respect to x, but with respect to t.
2 pi r?
So 2, I'm going to do this in red because we're taking the derivative. So
Equivalent to the circumference.
close, but it has things.
Oh.
2
Oh.
pi r and
Right.
r prime, yeah. There it is. All right, circumference. What is the equation for circumference? Ben gave it to us, so someone else, Arrow, you want to give it to us?
2 pi r.
2 pi r, and therefore the derivative of circumference, Arrow, is?
It's 2 pi r prime.
2 pi r prime. There it is. You don't have to memorize the derivative, although it is helpful to just know the shortcut, which I'm about to tell you right now. But if you just memorize, and by the way, the AP test assumes that you do have these memorized, I believe. Anything else like the volume of a, I don't know, triangular prism or something like that? No, not a triangular prism. The volume of a pyramid, they'll give you a formula for that, but there are basic equations that they assume you know. These are 3 of them. Well, 2 of them, I guess, because you really should just know radius. Shortcut. Notice the relationship between A prime and C prime. Notice the rate of area and the rate of circumference. How do they relate to each other? A prime is equal to something with C prime in it. Here's C prime, but what do I have with C prime as well? R. Yep. C prime with an R. C prime times R. There's your handy dandy shortcut. You'll probably be using that shortcut in, I would estimate, 40 to 50% of your problems. But you don't have to use it. You could just do it the long way of writing out all the variables. There's your nice and fancy shortcut. And just to give you a visual, I guess right there and right there, those blue things, that is just C prime. Okay. Let's do ejemplo numero uno and talk about units, and we'll be done. Oil spill. Do we have a beautiful voice? We have 3 beautiful voices. Do we have a beautiful voice that wants to share? Yeah, Rochelle, go for it.
Oil spilled from a tanker in a circle whose area increases at a rate of 40 feet per second. How fast is the radius increasing when the radius is 50 feet?
Interesting question. So we can visualize what's happening. And the first step in every single problem is to draw a picture. You might not need it, but I just like to draw that picture. I'm going to do it off to the side over here. There's my circle. Sound effects whenever you're drawing cool pictures because it makes it way cooler. And we have a radius for that circle. So we know that the radius is 50 feet. It tells us right there, radius is 50 feet. So I'm going to make that 50 feet on my diagram. What else do we know? We know that the area, we're talking about the area, increases at a rate. All right, so are we talking about A here? What are we talking about? Area is increasing. It would be A prime, yeah. So let's go ahead and just label that right here. A prime.
How would you know it's A prime?
Ooh, good question. Arrow, do you think you can answer that? Or maybe Ben can answer it?
Well, no, I didn't take a guess, but it's like if, okay, this is a really bad way to explain this, but if it was on a graph, the rate of change is something prime usually.
Yeah. And we're going to get to that formally when I talk about units down here, but A prime is a rate. If it says rate, and that's our key thing, if it says rate, it's going to be something prime.
So if it was whose area increases at 40 feet per second, that would just be A?
Well, feet per second is still a rate. If it says the area is 40, then it would just be A. If it said it, yeah, rate or something per second is going to be a rate. Yeah, I'm going to leave that box because that's kind of important too. We'll get to that a little bit more formally down here when we talk about units. All right. And do we have any other information that we need? We know we're a circle. We know we have an A prime. We know we have R. What are we looking for? What is our question mark?
R prime.
We're looking for R prime. R prime, we're just going to set that equal to empty box. We don't know what that is.
R prime of 50.
Yes, if R prime is a function of R, then it would be R prime of 50, but I think it's a function of T, so it's not going to be R prime of 50. Usually everything, when we talk about related rates, I would say, yeah, just 100% of the time, it's going to be with respect to time. I don't think it's ever with respect to anything else in all of the AP tests that I've taken. So we have our 3 pieces of information. We also know our formulas up here. We know that we're going to be dealing with A prime, so let's go ahead and write out the formula for A prime. A prime is equal to, and if you don't have it memorized, go ahead and rederive it. You know A is pi r squared, so A prime therefore is what?
So it'd be pi times 50 to the second power. I mean, yeah, so 2 pi times 50
There's our
times
50
R prime.
times R prime. There it is, yeah. And then this was our R here. So I'm going to plug in 50 as Rochelle told me, and I got that from down here at 50. Is there anything else that I can plug in?
Pi?
So yeah, pi, I can just say that's pi. We'll just say, leave it as pi.
Oh,
Don't
A
approximate.
prime.
Oh, A prime. What do we know about A prime?
It's 40.
Oh, okay, so we can say this thing is 40 here. Why do we have lag? I need to figure out why is equal to 2 pi. There's our 50 right there. There's our R prime right there. I love color coding. It looks so nice. All right. solve for r prime. We only have one variable. Do it. What is r prime? I know I have 100 pi here. If I simplify, 40 is equal to, I love colors. Let's switch this to 40 is equal to 100 pi times r prime. Therefore, r prime is equal to something with pi in it. I agree. Simplify the fraction. It becomes
2 over 5 pi.
2 over 5 pi. Box our final answer. Done. There it is. 2 pi, 2 over 5 pi. So you're wrong because you didn't use units. I'm sorry, but every single problem for related rates has units.
So feet per second.
It is always feet per second. Yeah. So if it gives you a rate, that rate is going to be the same rate for r prime. So let's go ahead and give ourselves feet per second. And that's kind of key too on the AP test. AP test, if you have a free response question, it's not multiple choice, you need to have rates on there. Be careful.
If we don't do that, do you think they'll cancel points?
Oh, definitely. 100%. I've taken quite a few. And not only do you lose points, but if you forget it once, they'll take off the points for all of your units. Because the way that the AP test works is for related rate problems, they will give you 1 point in total for all of your units, and you have to use units for A, B, C, and D. And if you forget it in B and do it for A, C, and D, they will take off that entire 1 point.
Whoa.
Yep. Now you know. Thank you, John, by the way, because he taught me that. Let's go to units here. A, our units are going to be, and I'm going to give you an example here. I don't want to keep it too general because I think it'll be confusing. Let's just keep it in, I don't like imperial. Let's go to metric. I'm going to keep it, we'll say like centimeters per second. Or sorry, centimeters. So area, centimeters what?
Squared.
Centimeters squared. What about circumference? What units do I have if I'm keeping along with my analogy of, or my metaphor of using centimeters, my example of using centimeters? Is it centimeters, centimeters cubed, squared? What are we doing
Still
here?
be centimeters.
Just centimeters, yeah, because it's measuring distance that I'm walking around as an ant, walking around the outside of a circle. What about radius? Also centimeters. Nice. Okay. Now, if I take the derivative, if I talk about a prime, I am now still with centimeters squared, but now per, we'll do per second, right? Per second. If I take the derivative, if I have a prime, I'm now talking about the same unit now per second. If I have c and I do c prime, I'm now talking about what? What would be my units?
Centimeters per second.
Centimeters per second. And Rochelle, radius prime, what would that be?
Centimeters per second.
There it is, centimeters per second. What about a double prime? Ben, you want to give it a shot?
Well, it's the rate of change in the rate of change.
Exactly, yes. So you said it correctly.
Whether it's increasing at an increasing or decreasing rate. So,
Yeah. So there,
centimeters per second.
that is exactly how you say it.
Wait, really?
That is exactly how you say it. But there are two ways of writing it. I will show you both ways. Centimeters per second
Centimeters
per second. That is one way of writing it. But the more formal and easier way of writing it is per second squared. You could have a double fraction, or you could just say per second squared. Therefore, arrow, what is circumference double prime?
Centimeters per second squared.
Per second squared. And Rochelle, therefore, radius double prime is
Centimeters per second squared.
second squared, yeah. So just know this in the back of your head. If it is talking about a rate, if it gives your units in centimeters per second, and you're talking about circumference, you are not looking for c, you are looking for c prime. This is a cool little key of telling you, oh, it gives your units as feet per second. It didn't even use the word rate. Haha, I already know I'm going to be talking about r prime, or c prime, or a prime, because I know that rate. So that's a key. You're going to be using this same key with different things. Like, for example, when we talk about spherical related rates, we're going to be talking about surface area and volume. But you know, if I'm talking about volume prime, I'm going to be talking about something per second. But if it's just volume, it's just that unit, not per second. So you can kind of use this analogy, or use this and kind of apply it to other scenarios. That's kind of how math works, just linking ideas. Any questions? All right, that concludes the notes.